All right, let's dive right in. Today, we are going to pull back the curtain on a piece of everyday magic, something you've probably used 1,000 times and never really thought about: the humble vacuum flask. The thermos. I mean, have you ever stopped to wonder how it actually works? How does this one simple looking bottle keep your coffee piping hot or your water ice cold for like the whole day? Well, that's the big mystery we're going to solve right now. Turns out it's not magic at all. It's just some seriously clever science. You see, the entire design of a flask is basically a high-tech fortress built with one single mission in mind. And that mission is to stop heat dead in its tracks. Whether it's keeping the heat in your soup from getting out or stopping the summer heat from getting into your iced tea, the goal is exactly the same: put a stop to heat transfer. So, to understand how it wins this fight, we've got to look at how it's built. We have to peel back the layers because its construction is where all the secret sauce is. If you were to slice one of these things right down the middle, you'd see it's not one bottle, but two. It's a bottle inside another bottle, only connected right at the very top. And this creates that all-important gap between them. Then, of course, you've got the stopper that seals the whole thing up. Every single one of these parts has a crucial job to do. Now, to really appreciate the flask's genius design, you gotta meet the enemy. Heat is pretty relentless, and it likes to travel in three main ways. You can think of these as the three villains the flask is engineered to defeat. First up, you've got conduction. This is just heat transfer by direct touch. You leave a metal spoon in a super hot cup of coffee, and pretty soon the handle is hot, right? The heat literally travels up the spoon as all the little molecules bump into each other and pass that energy along. That's conduction for you. Villain number two is convection. This is heat that moves through liquids and gases. You've definitely seen this before. You know that wavy, shimmering air you see over a hot road in the summer? That's hot air rising. The heat is literally being carried by the air itself. That's convection. And our final villain is radiation. This one's a bit different. It's heat that travels in the form of invisible waves. And here's the crazy part. Radiation doesn't need any stuff to travel through. It can go right through the vacuum of space. It's how we feel the sun's warmth from millions of miles away. So how in the world does a flask fight off these three powerful forces? Well, its main weapon is actually nothing. And it is the ultimate force field against our first two villains. Remember how we said both conduction and convection need molecules to pass the heat along? They need stuff to travel through. Well, the brilliant solution is to just get rid of all the stuff. In that gap between the inner and outer walls, they suck out all the air, and that creates a vacuum. This really says it perfectly. With no air molecules in that gap, heat just hits a dead end. It can't jump from the inner bottle to the outer bottle. That vacuum is like a bridge that's been completely removed. Heat simply cannot cross. Okay, so it sounds pretty foolproof, right? A total shutdown. But there is one tiny little weak spot. Those two walls have to connect somewhere, and that happens right at the neck of the flask. That's the one place where heat could try to sneak across. And that's where the stopper becomes the unsung hero. It does two critical jobs. First, it plugs the opening up tight, so no air can get in or out. That stops convection. And second, it's made of a material like plastic or cork, which is a terrible conductor of heat, so it effectively blocks that last little pathway for conduction. So conduction and convection are defeated. Two villains down, one to go. But what about radiation? Those tricky heat waves can shoot right across the vacuum. The flask needs one last trick up its sleeve. So yeah, a vacuum is totally useless against radiation. You can't block it with nothing. So what do? Well, if you can't block it, you bounce it. The solution is a mirror, an incredibly effective defense that's built right in. The inner bottle of the flask is coated with this super reflective silver layer. It basically turns that surface into a heat mirror. It reflects those invisible heat waves exactly like a regular mirror reflects light. And what's so cool is that this works both ways. If you have a hot drink, the heat trying to radiate out gets bounced right back into your coffee. And if you have a cold drink, any heat from the outside trying to radiate in gets reflected away. It's a perfect two-way shield. And when you put it all together, you get to this really profound idea. The absolute best insulator in the world isn't some fancy foam or some space-age fabric. It's nothing at all. It's the simple, elegant power of having no material there. So, the next time you pour a drink from a thermos, you'll know you're not just holding a bottle, you're holding this incredible little fortress of physics. And it kind of makes you wonder, right? Now that you know its secrets, where else do you see this amazing science at work? Think about it.